Hello, everyone. My name is Aviana Calderon, and I am here to present my action research project. My action research project is titled Horizontal and Vertical Planning in the Mathematics Classroom, and I am a student here at Columbus State University pursuing my EDS and middle grades education with an emphasis in mathematics. Vertical planning in a math classroom involves aligning curriculum, instruction, and assessment across different grade levels to ensure a coherent and connected progression of mathematical concepts. And this approach supports students' learning by building on prior knowledge and preparing them for future topics. So, what exactly does that look like? This looks like collaborating with grade level teams to schedule regular meetings with teachers from grade levels above and below to ensure that they address any educational gaps and ensure there's no unnecessary repetition from grade level to grade level, which also allows the current grade level teachers to focus on the deficits rather than repeating the same material across the grade bandwidths. The literature review that supports these statements starts with a vertical professional learning community, or what we commonly refer to as PLC, happens when a team of educators come together to see how standards, curriculum, assessment, and instruction align within the school. It's most effective for a vertical PLC to be made up of all teachers within the same department or contact area and span across grade levels. So, for instance, I teach eighth grade currently. So my vertical professional learning community would consist of sixth grade teachers, seventh grade teachers, and eighth grade teachers that all teach mathematics. And strategies for achieving vertical alignment means communicating and coordinate between grade levels, use data to identify gaps and bridge them, and incorporate different teaching modalities and utilize technology. Vertical alignment planning supports curriculum coherence, reduces redundancy, and enhances the progression of learning, contributing to improved student outcomes and a stronger teacher collaboration. So, horizontal planning. The definition of that is horizontal planning in the math classroom focuses on ensuring alignment, coherence, and consistency within the same grade level across different classes or sections. This approach emphasizes collaboration amongst teachers teaching the same grade to deliver a unified experience for all students. So, what exactly does horizontal planning looks like? It allows educators to align curriculum and pacing by developing a shared pacing guide to keep all classes progressing at a similar rate and design common assessments to evaluate student understanding and monitor trends. A literature review to back up those statements says horizontal planning involves the coordination of curriculum, instructional strategies, and assessments amongst teachers of the same grade level or subject to promote consistency and to address shared learning goals. Also, horizontal alignment ensures consistent delivery of curriculum and equitable learning experiences while fostering teacher collaboration and research sharing, ultimately benefiting student outcomes. So what this would look like in my current educational setting is that my horizontal planning is a PLC with just our eighth grade math teachers. The research focus for this project was what are the positive and negative effects of horizontal and vertical planning, and does horizontal and vertical planning actually increase student learning? So for my mythology, the setting for this research took place within the Douglas County school system, which is located about 45 minutes west of Atlanta. The current school that I teach at is called Factory Shoals Middle School, and that is where this learning took place. So the school population is around 820 students, but since I just did this research on my specific class, it took place, give or take 60 students participated in this study, all within grade 8. So the treatment to conduct this research was that one class will be taught using materials created during our vertical and horizontal planning processes, and the other class will be taught using materials solely found by the classroom teacher, which was myself, that were not created or discussed during the vertical and horizontal planning. That way I was able to compare and contrast the test data to see, does vertical and horizontal planning have the actual benefits that um, my principal solely thinks, or um, is it better to find resources and materials that are geared to the students in your class? So the demographics by my class, as I stated before, um, my research was conducted on 2 classes. I teach 4 total, but decided to just conduct the study on 2 classes. So the first class consisted of 20 students. There are 9 females and 12 males, and 19 African American students and 3 Hispanic students. The current school that I teach at is about 93% Hispanic and African American, so that does take the bulk of the demographics as my um in my class. So that would explain why class 1 solely has just those 2 demographics in it. Class 2 consisted of 25 students, 7 females and 18 males. We had 21 African American students, 2 Hispanic students, and 2 Caucasian students. So the unit of study that I conducted during this research was geared towards standard 8 FGR 5.5, and it is write and explain the equations y equals mx plus b, which is what we know as slope intercept form, ax plus by equals c, which is standard form, and y minus y1 equals m multiplied by x minus x1, which is called slope point slope form, as defining a linear function whose graph is a straight line to reveal and explain different properties of a function. And the picture out to the side is the formulas that students had access to throughout the entire unit. That way they didn't have to memorize the formulas right away. They had something to refer back to. So eventually, by the end of the unit, the goal was for them to have these 3 formulas memorized and be able to convert between the 2. So for my case study, the experimental group will receive instructional materials provided by the teacher. Teacher materials have been researched to align with the Georgia Performance Standards. So for my case study, again, I had 2 groups, the experimental group and the control group. So each class will participate in one of these groups for 3 weeks, and then they will switch. So for the first 3 weeks, class 1 is one group, and then class 2 is another group. They will take an assessment, and then they will swap, and then they participated in those groups for 3 weeks, and then they took another test. So there was a total of 2 formative assessments, and then the data will be analyzed to determine if vertical or horizontal planning increased student learning, or was the data skewed and there's really no difference. So some of the resources that I used for the experimental group, these were resources that I found on my own, ensuring that they aligned with the standard that I listed previously. This is not all of the resources that were used. These were just 2 that were used during this time. So the first resource that we have here on the left shows students taking 2 points on a coordinate plane and plugging them into the slope formula to find the slope of a line. And then the second resource we have here on the right is that we have a empty coordinate plane, and then we have a formula, and the goal is for them to graph that line on the coordinate plane. And here are two more resources that we used throughout this time that I found and gave to the students, again, ensuring that they aligned with the performance standard. And so on the left, students are finding point slope, and then on the right, students are using the standard form formula to go from standard form to slope intercept form. Now, my case study. The control group will receive instruction created during collaborative PLCs with the other 8th grade math instructors. This instruction will heavily involve the Desmos curriculum, as that is the official math curriculum for the Douglas County school system. Additionally, the control group will continue to follow the average day-to-day schedule that students are accustomed to, while the experimental group will take a pause in using the Desmos curriculum and will use teacher research materials during that time. So some of the control group sample resources, these came straight from the Desmos website. We have we have 8.3 lesson 6. So for the Desmos curriculum, this was unit 3. Lesson 6, 7, and 8, and that all dealt with slope intercept form, point slope, and standard form. And here is just another resource that was used during that time that, again, aligned with the Desmos curriculum. As you can see at the top, this came straight from the Desmos curriculum. That is a strictly online platform. Here is a resource for students to complete their online work straight in the Desmos curriculum. What I like about the Desmos curriculum is that not only does it have the notes, it also has practice problems for the students to complete. So this is a sample problem that students actually completed within the platform, and it says calculate the slope of each line and then click on the appropriate cell in the table to highlight the line you are interested in. So again, they're taking those two coordinates that are listed on each line, they are plugging it into the slope formula to find the slope of each line. And again, as I previously stated, students completed a formative assessment at the end of each experiment. So they learned the material for 3 weeks. They took a formative assessment. They switched groups, and then they used that curriculum and materials for 3 weeks. And then they took another assessment. So here on the screen are just some sample questions that some students saw on their formative assessment. And each formative assessment was about 15 questions long. So as you can see, this is just some that I pulled from that assessment. So before I get into the results of the student assessment, I wanted to make note that for this unit, I did not give a pre-test. For past units, pre-tests have been given if the material has been taught to them in a previous grade. But with this being slope, this is a brand new unit that is not typically introduced until 8th grade unless students are in an advanced or accelerated math class. Being that I just teach general education math class, there was only maybe 1 or 2 students that have previously taken an advanced course and then got moved to general education. So instead of giving a pretest, I just used our iReady diagnostic to give a sense of the levels in the 2 classes that I conducted my study for. The iReady diagnostic is what you would refer to as your benchmark. It just gives students a variety of questions, and then at the end it allows you to see which grade level that they are performing on. So for class 1, I had 2 students test on 8th grade, 7 students test in 7th grade, 3 students test in 6th grade, 2 students test in 5th, 3 students test for 4th, and 4 students test in 3rd grade. And then for class 2, I had 1 student test in 8th grade, 6 students test in 7th grade, 3 students test for 6th grade, 6 students test for 5th, 3 students test for 4th, and 5 students test for 3rd grade. And again, this diagnostic was given in August. So if I were to give this diagnostic again, the information might be a little bit different, but this is the baseline that all of the math classes were given to see what levels our students are testing at and where we might see the deficits as we're going on with the 8th grade math curriculum. So my data analysis and findings. So for assessment 1, my I went with class 1 to be my experimental group. I chose class 1 to be my experimental group in the beginning because those students tested a little bit higher on their iReady diagnostics. So I knew that a change in their routine might not throw them off as much. Whereas class 2, I could prepare them for the change in routine. Um, that way it was gradual. So for class 1, again, I chose that to be my experimental group for the first 3 weeks. And I used those teacher researched graphic organizers and notes that I showed previously to begin teaching slope. And after the first assessment, I had 2 students make an A, 4 students make a B, 4 students make a C, and 12 students make an F. 1 student was not tested, and the class average was a 63%. And class 2, again, they continued on with their normal routine using the Desmos curriculum for those first 3 weeks of teaching slope. And then they took their assessment, and I had no students make an A, 4 students make a B, 4 students make a C, and 17 students make an F. And all students were tested at this time, and the class average for this class was a 55. Now for assessment 2. Class 1 was a control group. So again, those students use strictly Desmos curriculum instruction and resources. And this was for the second set of 3 weeks. And after they took that second assessment, I had 2 students make an A, 0 students make a B, 3 students make an F, and 3 students make a C, and 15 students make an F. 2 students were not tested, and the class average was a 57%. During this time, we did have a lot of new students enter our school, and we also had some students change classes for scheduling purposes. So I didn't have as many students take the second assessment. Unless they were here for the entire 6 weeks. So that is why this assessment, there are more students who did not test because they were not here or they were not enrolled in my class for the entire 6 weeks, and I didn't want it to be unfair for them. Class 2, the second time around, they were the experimental group, so they used those teacher-made resources that were shown before. And so 2 students made an A, 3 students made a B, 3 students made a C, and 13 students made an F for a class average of a 66%. So if I were to, and here are my resources that I use to come up with my literature review. And if I were to say any results for my findings, I would say that although the experimental group did perform a little bit better each go round than the control group, the fact that the class average was still below a 70%, I don't think that there was enough time to conduct the research to see if um, teacher research materials are outweigh the curriculum that is required of us in my school system, which is the Desmos mathematics curriculum. I think going back to my iReady diagnostic, I think with any curriculum that you are given, there needs to be more students that test and have the ability to test closer to grade level for any implemented curriculum to work. So as you can see with my test data, there are a lot of students who did make an F both times around. But going back to my iReady diagnostic testing, you can see that there's also a lot of students that are not testing on an eighth grade level, but more so not testing on a middle school level at all. So if I'm teaching students that are testing on a third, fourth, and fifth grade level, it is going to be a stretch to get them to eighth grade level math where they can show mastery with any curriculum that is used because they simply just do not have the basic mathematical skills down yet. So to sum up or to wrap up, I do think that yes, the teacher made materials did help because I was able to cater and find resources that I knew would make sense to my students. However, I don't think it's enough to say um, if that is the best method over using the mandated curriculum that is provided by my school system. Thank you so much for listening.